Taking example 2, so we're supposed to find the area between these two curves. In this case, we're not given any kind of interval, so we have to figure out what the intersection points are. We can do that by setting the two functions equal to each other. So we get x to the 1/4 equals x squared. To get rid of that fourth power, or the 1/4 power, we can raise both sides to the fourth power. And so that'll give us x equals x to the 8th power. To solve this, we're going to want to move both of the terms to the same side. So we're going to get x to the 8th minus x is equal to 0. We'll factor out an x. X times x to the 7th minus 1 equals 0. So that tells us that x equals 0 and x to the 7th minus 1 equals 0. We can solve this one by moving that 1 to the other side. X to the 7th is equal to 1. The 7th root of 1 is 1, so x equals 1 is our other bound. So what we're going to want to do to find the area here is find the integral from 0 to 1 of, and now we have to decide which function is the larger one. If you do graph these on the calculator, this kind of looks more like a square root function, so it's kind of a more sideways opening parabola. This is a typical quadratic that's opening up. This is going to be the larger function, but if you wanted to verify that, you could plug in a number like 1/2 or something like that, and you'd find that 1/2 squared is actually smaller than 1/2 to the 1/4 power. So this is the larger function, so it goes first. So we get x to the 1/4 minus x squared. That's the integral we want to find. So antiderivative of x to the 1/4, raise that by 1, we're going to get 5/4, so we'll get 4/5 x to the 5/4 power minus, that's going to be 1/3 x cubed. You want to evaluate this between 0 and 1. Plugging in 0 is nice because it's just 0, so really all we got to do is plug in 1. If you plug in 1, well, 1 to any power is still 1, so we'll get 1 to the 5/4, 1 to the 3rd is 1. So basically our answer is just going to be 4/5 minus 1/3, which is 7/15. So the area between these two curves is 7/15.